Welcome back to another Microsoldering Wednesday. My name is Derek, and today we're going to be taking a look at a Nintendo Switch Lite that's not turning on. Now, the original known issue was a charge port repair, but sometimes when charge ports get damaged, they can cause further damage with the motherboard because things short out and it can cause issues. Let's take a look at this motherboard and see if we can determine the issue and how to fix it. Let's get into the video. Now, there are a couple things that you'll want to have if you're looking to get into motherboard repairs. One of them is obviously a multimeter. This will allow you to help isolate issues, find shorted lines, test resistance, voltage, and a bunch of other things. You'll also want to have a power supply. This will allow you to inject voltage into the device to troubleshoot it. And a couple other things that you should have would be either a thermal camera or understanding the concept of using freeze spray if you're trying to find a short. There are other methods, but those tend to be the easiest. Here's the Nintendo Switch Lite motherboard that we're going to be taking a look at. So let's get started. Alright, so the first thing that we're going to do is we're going to test the battery line. So what we'll do is we're going to put a red probe on ground. It can be anywhere that's grounded. And we're going to check the battery line. So when we go and we test here, we get a 0.22, but it's like changing slightly. That's not exactly what I'm looking for, but it's close enough that I wouldn't suspect it right off the bat. And if we check the other line, we have 0.557. So that right there is interesting. So what we're now going to do is I'm going to grab power supply and we're going to set the voltage to 3.8. Okay. And if you're ever curious what voltage you want to set it to, all you have to do is look at the battery line. All you have to do is look at the battery and it'll tell you on there what it is. This one in this case, all you have to do when you're trying to determine what voltage you use, just look at the battery, and this one says 3.8 volts. It's the same for an iPhone, any electronic. You just look at the battery and that's how you know what you need to put into the board. Alright, so let's take a look and see if we get any spike. So when we touch these to the battery line, we should not get a spike if there's no issue with the board. So what we'll do is, in this case, we'll put the black probe on ground instead of the red probe because we're going to be injecting voltage through the red one because that's one I have connected to the positive side. And when we touch it, we get an automatic spike 2.139. Okay, this should just read 000 until I hold down like a power button, for example. So something's happening on this line, or at least a line that's connected to the battery line. So let's take a look and see if we can isolate the component. And the best way to do this is with a thermal camera. Alright, so when we go to put power to the switchboard here, there's my black probe on metal on the charge port. And we'll touch this test point for the main battery line. And I get a 0.137 draw on the power supply, and you can actually see starting to heat up in this area. So let's do this. I'm going to flip it over. This is going to be a little tricky, but I'm going to put it here on the battery line, and then we'll touch ground, and boom, look at that. We got a nice short there. So this component right there is the culprit. Let's go and take a look under the microscope at that. Alright, so we're going to come in here and I'm just going to really make sure we've isolated the exact right component. Okay, we've got some frost on there. Let's see, it's already starting to melt. 1 second. Ready, set, go. Okay, perfect. As you can see, when we just tap it, we get this one is the only one that melts. So we know that that is the cause of the short. So there you can see we've got the ALJ929 chip. So now that we have isolated this component, as the failure component, we need to find out what it is so that we can order and replace it. With a little bit of research, typing in the letters on top, able to isolate that this component is the charging LDO regulator boost IC for the Switch for the Nintendo Switch. I can't expect mobile-centrics to have everything. Can't expect mobile-centrics to carry every single part of the Nintendo Switch that fails. So I've added some flux. Let's go ahead and pop that guy off. Now let's see if it has any power draw now. Let me connect up the power supply. So we'll put our black probe on the port. There is absolutely no draw there anymore. Let's see if we have any issues here. That reads 0.46. This out one is shorted is to ground. This one's 0.49. The 0.062. The center one's same, 0.062. That's ground. Okay. So all three of the outer ones are ground. That doesn't mean that they should be. I'm not sure. I don't have a schematic, but let's see if it tells me anything just looking at them under the microscope. So let's zoom down on in there. All right. So looks like these bottom two are connected together. These middle two are connected together, and these top three are in fact supposed to be ground. All right. So we've got our components. Let's take a look at it. So let me show you how to quickly replace the charging LDO regulator, boost IC. Take a little bit of solder paste here. Take our soldering iron. And we'll mix it with the pads on the board. Just like that. Now we'll get out some wick. Add a bit of flux. Take a little bit of isopropyl alcohol and a brush, and we'll clean off all of the burnt flux, and we'll make sure they're nice and clean, ready for the new IC. Alright, we'll add a little bit of flux. We'll get out a new IC, and we'll make sure we get this nice and aligned. You can see that it's pretty bald. We'll want to make sure we can read it and that it's in the proper orientation. So as you can see, we've got it still like this, AJZ. So we'll line it up. We'll come in with the hot air. We'll let it snap down into place. Give it a little nudge. Let it cool down a little bit. Looking under the IC, although it's kind of hard to tell, all of the solder joints look good. See, it's all nice and pancaked out. Alright, so here we've got the motherboard under the thermal camera. And although I used the power supply before, what you can also use is a charged up battery. So what I'm going to do is we're going to connect up this battery. And what we hope not to see is any draw of current. So here we go. And look at that. We don't have it drawing anything. There's no hot spots anywhere. There's nothing that's getting hot. That means that we're probably working. So let's go disconnect this. Let's go plug it all up into the housing and let's test it. Alright, and just to confirm again, what we're going to do is we'll go ahead and touch our black to ground, our red to the battery line, and we have no amp draw. So no longer have the shorted line. So that's really good. Alright, let's reassemble this enough to at least test it. So we'll slide the motherboard in, making sure all of the cables are out of the way. We'll go ahead and connect up all of the flex cables. We'll even connect up the speaker on this side. Connect up the fan. We'll even connect up the coax cables just to kind of get them out of the way. We'll even connect that guy up. Alright, so main thing we're going to do is I'm going to actually connect up a charged battery, or at least one that has partial charge. Okay, we'll plug in this ribbon flex so we can use the power button, and we're going to see, carefully holding everything still, if we get it to turn on. So here we go. Test the power button. Oh, look at that. We have no image, but it is on, which is a good sign, but because it wasn't even booting up before. So we have image. All right, we got fan spin. We don't have image, but it is on because I can hear it the touch. Well, probably playing a game now, so I'm going to double check and make sure I have all the connectors in there. But we'll go ahead and disconnect the battery for now. A lot can go wrong when these ports get damaged. It can kill a lot of components. So I'm just going to double check my connections on everything and we'll test it again. Alright, well, it's amazing what a little bit of cleaning of the camera lens will do. I can't believe I thought it was an issue with the camera. Alright, so taking my multimeter, this IC has a lot of responsibility for image output. So what we're going to do, I'm just going to test around real quick and see if we get any issues here. I wish I had a schematic. Okay, there's potentially an issue here. This looks like a capacitor, not a coil like these ones. This looks like a capacitor and I have continuity across it. I wonder if this IC has failed and or if there's something going on here. I'm going to quickly pop off this IC and see if that takes care of the short there. Alright, it says max 77620. Alright, with the plus here, we'll remember that orientation. Now that it's a little warm, take some flux. As soon as I start to see movement, we can lift it off. I'm going to set it here on the side real quick. And we still have this short going across there. At least I think it's a short. I wish I had a schematic. Alright, so let's take a look as well. I forgot to look at this circuit, and it looks like everything around this IC is appearing short. So let's pop that guy off real quick and check for the shorts, see if they're gone. Alright, again, this one says max. The X is here, the arrow's there. Just waiting for it to start to move with the tweezers here, just nudging it. No movement just yet, barely touching it. There's some movement, so I can lift. Let's let the board cool down a little bit and we'll test it. Interesting. I'm going to hit this with a little bit of flux and we're actually going to put that chip back real quick. And we'll go back under the power supply and test it. Add a little bit of flux. Alright, now let's go under the thermal camera now that that guy's back on and we'll check for a short. Alright, so if we inject some voltage into the shorted line there, it gets hot in this area. Alright, let's pop off the shield here. Alright, so we got the shield off there. Let's test one more time. I inject a little bit of voltage into the shorted line. Immediately what gets hot is the CPU, which is unfortunate as that means that the only solution could potentially be a reball of the CPU, but I highly doubt that that'll solve it given the extent of the damage to the charge port that caused the device not only not to charge but not display image. And of course the capacitor that was shorted on the backside, when I go to test it as well, it's connected straight to the same spot, CPU. Off camera I did a reflow of the CPU because I was about to give up on this repair. I was able to heat it up, nudge it, get it to move. So I'm going to go ahead and put back all of the components and we're going to see if that fixes the short that we were experiencing. Take our iron and we're going to mix it with the factory solder. Let's get some fresh wick out, a little bit more flux, and we'll wick it all up till we get it nice and even like that. We'll clean it up with some isopropyl alcohol and a Q-tip. Add a little bit of flux. We'll get out our max 77620H IC. As you can see, it's pre-volled for us. We'll line it up and we'll come in with our hot air. We'll flow it into place. We'll watch for it to drop. There, it's kind of shifted into place. Haven't yet seen it drop yet. There's some movement. So we want it all the way drop. Come on. Drop, drop. There it drops. And we'll nudge it. There we go. Alright, we've got everything kind of connected back up. Let's see if we can get any life now. Alright, we've got the battery connected. Let's go and touch the power button. And there we go. I'm going to take a look and see if I can figure out what this error is. Alright, let's connect up the battery and see if we can find any hot spots. When we go to turn it on, plug in the flex cable here. Okay, so we get a nice little hot spot coming from there. So that's the backlight IC there, but that's not hot per se. I think the hot area is coming below that. You can kind of see. Alright, given all of the solder paste that I see kind of strewn around here, I think I'm going to go ahead and replace this guy as well, just to rule him out, because this could be causing that error that we were seeing. So this is the BQ24193 IC. It's the battery charging IC. Alright, so we're going to get a new one here. We'll take off this old one. Keep in mind the dots in this corner, or we have the arrow right here. Okay, got some flux. Add a little bit of solder to it. Add a bit of flux. Alright, we'll add some more flux. Line up our chip. We got the squeeze out I do like to see. Now we'll come in with our soldering iron and we're going to clean it up. Now that I've got that cleaned up, we're going to go in and flow it one more time just to make sure it's as squared up as possible. There we go. Alright, now that we've replaced that other battery charging IC, let's go ahead and see if we still have that error or not. So here it turns on. We still have that error. Alright, I'm going to take a look. Maybe it's just the IC. Alright, now that we've got that guy replaced, looking good. Something right there. Get rid of that. All the damage that happened here causing that IC to go bad. There's a lot that could potentially go wrong. Okay, so we've got that IC replaced. We'll connect up the battery that has some charge to it. Plug in the ribbon so we can turn it on. Alright, moment of truth. Do we get past and not have an error? Okay, there's the Nintendo Switch. Yes! Alright. Alright, so there we go. We now have a working Nintendo Switch Lite. We started off with a completely dead board. It wasn't receiving any power. In fact, when you put power into it, we saw the short circuit on the LDO. And even after that, we still had no image, still had a charging issue. And I think I got lucky with the CPU reflow. I honestly thought that I was going to have to call it at that point. So a CPU reflow or even a reball is kind of a last resort in these cases, where the short goes straight there and there's nothing else. That short was able to be relieved with a reflow, which I thought was a long shot, but I'm glad that I took it. I seriously wish that I had schematics for this device, for the whole motherboard, so I could troubleshoot any issue that it had. If there's anything that you have to add, leave it in the comments below. And if there's something that you'd like to see in a future video, let me know. Thanks a ton for watching. We'll see you in the next video.